Fantastic. You can see that all?
Yes.
Fantastic.
Okay.
Brilliant. Should I start?
Okay.
Or do you want to give an introduction first?
Yes. Okay. So welcome everyone to Scientia Science Writing Internship Cohort 4. And today is the last webinar of our series. And today we have been blessed. We are honored to invite Dr. Jörg Matthias Determann from Qatar. And Dr. Determann is a very well-known researcher in astronomy. He's a professor of history of science at Virginia Commonwealth University, Qatar, and he has been associate editor at Review of Middle East Studies, published by Cambridge University Press, and he has been researching on different topics such as diversity, inclusion in astronomy, and history of science and science fiction. He's a prolific writer. Besides this all, he will be telling us about his writing journey and how he just had his recent book published earlier. And thank you, Dr. Determann, for joining us. Over to you.
Thank you so much. Thank you for having me, Foz. Thank you, Sadiqa, as well, for your support. I can see you in the audience. Thank you for your social media support to both of you, Foz and Sadiqa. Big thanks to the entire Scientia Pakistan team for having me again. It gives me great pleasure to talk to you about researching diversity, equity, and inclusion in astronomy. That is also the title of a book of mine, my most recent monograph on diversity, equity, and inclusion in astronomy. But it is a topic that I think everybody can research, and that includes all of you, and that everybody can write about. So all of you can write about issues related to diversity, equity, inclusion in astronomy. But you can write books about it, you can write journalistic articles, where you can write features in Scientia Pakistan, or you can just write on social media about that topic. It is a topic of, I would say, like universal appeal, and forgive me that pun perhaps. And let me maybe just start by talking about this background image here. Do any of you recognize that particular location? I know it's a hard question, it's a tricky question. Any of you recognize that particular image or that particular location where that image was made, or what is shown there? What can we see in that image? Do you recognize any object in the sky? Well, we can see
the band of Milky Way.
Yes, that's right. But we can see the Milky Way, and we can see mountains. Those are actually mountains in northern Pakistan, in Karakoram, so near that very, very famous second tallest mountain in the world, the K2, named after Karakoram. And so this is a specific location here in Pakistan where one could sort of have a beautiful view of the Milky Way. But maybe it doesn't matter so much where that location is, because theoretically it could be anywhere, right? Sort of theoretically, at least, anywhere on the Earth you could see the Milky Way. It is always there, right? It's our galaxy, we are part of it. But at the same time, and I think that's also the interesting tension, not all of us can in fact see the Milky Way. So if I can ask you, perhaps, any of you, if you step out at night in a cloudless sky, is there actually anybody of you who can actually see the Milky Way? I cannot see it in Doha, I should confess. There's too much pollution, particles, light pollution, other kinds of particles in the air. I can see it, yeah, but no, That's right. So not in Karachi, says Tanvir either. In a way, theoretically, we can all have access to the Milky Way, to the stars in principle, and humans have always in some way had access to the sky. They could always just look up, but at the same time, it's also this access is also becoming more exclusive, right? Most people around the world live in cities nowadays, and these cities have a lot of lights that obscure, in fact, the stars, right? Sort of, so being able to see the Milky Way is a privilege in 2025. So this brings us to the topic of inclusivity and exclusivity that sort of I found interesting when it comes to astronomy. You can explore it when it comes to other sciences as well. But with astronomy, I feel that tension is especially interesting and productive. What do I mean by inclusivity and exclusivity? So astronomy is perhaps one of the oldest sciences, right? It has perhaps existed for as long as human beings have looked up at the sky, at the stars, have just wondered about what is out there, have told stories about the moon, the sun, the planets, how their movements might affect or not the Earth. So we can find astronomy on every continent. So we can have hence books about African cultural astronomy. There's a huge tradition of Islamic astronomy. There's Aboriginal Australian astronomy. There's Canadian First Nations astronomy. So pretty much every community around the world has probably names for the star, for the moon, the sun, the major planets, and so on. At the same time, there is this exclusivity in that if you want to see the stars clearly, you have to go to remote places increasingly, right? You have to go to high mountaintops like K2 or other mountains in Pakistan or elsewhere. You have to go away from the cities, or you have to go into outer space altogether. So some of the most interesting discoveries nowadays are made by space telescopes, such as the James Webb Space Telescope or the Hubble Space Telescope. Telescopes that are in places that almost no human can reach, right, sort of in Earth orbit. And the kind of instruments that nowadays researchers use are very expensive telescopes. The James Webb Telescope has cost billions, as has the Hubble Space Telescope over the years. Building a giant telescope on mountaintops, again, is very, very expensive, making this in many ways an elite operation. So astronomy has this popular appeal. It has a great tradition of amateur astronomy, but at the same time, it has also a connection to like exclusivity, to elitism, and so on. Now, astronomy is also very interesting because it is a very international science, right? The stars don't belong to any particular country. Lots of countries have stars in the flags, but no particular country actually owns a star or owns the sun or owns the moon. If anybody tries to sell you ever a piece of the moon, don't buy it. Sort of the moon belongs to everybody. Whereas other sort of sciences have involved a lot of like secrecy. So for instance, nuclear weapons research. I know Pakistan has had a nuclear program for a long time. In neighboring Iran and neighboring India as well, there have been nuclear programs with some secrecy and around those programs and controversy. Astronomy, even though it's quite close to like physics, has for the most part never been secret. It has been sort of an open science, relying on open collaboration, open skies. And there are sort of books about international relations and astronomy that you can look at. Astronomy is also a field of research that people of all identities have always engaged in. Yes, it has a certain proximity to physics, right? A lot of astronomy nowadays is essentially astrophysics, and physics in general has often been a science related to elites and often science dominated by men. Well, I spoke about nuclear programs earlier. I'm not sure if any of you have watched the movie or heard of the movie Oppenheimer. If you watch the movie Oppenheimer, you will not find many female physicists, female PhDs, female researchers in that particular movie. Astronomy is different, right? Maybe because astronomy hasn't been used to develop secret nuclear weapons and so on. Astronomy has been a more open field. There have been more women in that field historically compared with other areas of physics. However, that doesn't mean that that it has been easy for women to make it in science. So, I mean, if you just look at the number of female Nobel Prize winners in the sciences, you would find very, very few, especially in fields like physics. There is Marie Curie, famously, who won a Nobel Prize in both physics and chemistry, so in 2 Nobel Prizes in 2 different sciences. Very, very remarkable thing for any human being, let alone for a woman. But sort of the small number of women Nobel Prize winners also tells you something, that it hasn't always been easy for women to make it in that field. Which also means that for science writers, it's an interesting field to explore. What are the kind of obstacles that women have faced? Well, all of us have some kind of gender identity. We identify as men, as women. We maybe identify somewhere on that broad spectrum of gender identities, as straight, queer, as LGBTQ+. Well, the same is true for ethnic and racial identities. We probably all have some kind of ethnic identity, and people from all ethnicities have always been interested in the stars, right? People from all continents, including people who identify as minorities in modern nation states. And especially for a science like astronomy, that requires access to elites, that requires access to fundings, to big machines, and so on, to big telescopes. It has not always been easy for people from racial and ethnic minorities, such as, for instance, African Americans in the United States, to make it in that field. And for instance, if you look at globally, for instance, the number of Muslim Nobel Prize winners in the sciences is still relatively small, right? If we think that there's somewhere between 1.5 and 2 billion Muslims in the world, and sort of how many Muslim Nobel Prize winners we've had in the sciences, we can see that it has been challenging for Muslims to get to those, to reach those highest honors. And again, that's an interesting story that can be told. What are the obstacles? What is the discrimination in the sciences for people from the global south, for Muslims, for people from, say it says only Dr. Abdus from Pakistan, right? Who, for instance, he comes from a specific minority even within Pakistan, right? So he's a scholar from the global south, but he's also somebody who comes from the Ahmadiyya community. So perhaps he has had multiple sort of challenges trying to make it in Pakistan, but also like trying to make it as a Pakistani scholar and scientist in America, in Britain in particular, winning the Nobel Prize ultimately. So he has a fascinating life, maybe even more fascinating than the life of somebody like Albert Einstein, who also left his home country, who came from a community that also faced discrimination. Albert Einstein being Jewish, having to leave Germany during the Nazi period. So there are sort of interesting lives that can be told, that should be told, and that maybe can be told by you. Now, we all have a gender identity, we all have an ethnic identity or racial identity, and we probably are all somewhere on a spectrum of ability versus disability. Most of us, if we are lucky enough to live long enough, we will probably encounter some kind of disability, experience some kind of disability. So if we live long enough, chances are that at some point maybe we become deaf or blind, physically impaired. So in some ways our capacities through accident, through aging, also will diminish. And a lot of astronomers, astrophysicists, cosmologists have experienced disability. There's John Goodrick, for instance, a deaf astronomer in history. One of the perhaps most famous disabled scientists in broadly the space science cosmology area is Stephen Hawking, subject of a film, The Theory of Everything. There are also like many other astronomers who have experienced hearing loss, vision loss, and so on. And all of those people are people who sort of are remarkable just in overcoming those particular obstacles in order to make it and have an impact in the sciences. Yes, we know a lot about Stephen Hawking, but there are probably many, many disabled scientists that we would love to have more writing about. I've tried to write about some of those astronomers, but there are many, many more that I couldn't write about, and that's perhaps materials that you can get interested in. Now, where do you find like astronomers, for instance, who've tried to overcome obstacles, who've tried to fight against discrimination, who've tried to make it as women in astronomy or as disabled people in astronomy? Well, you can find these increasingly at conferences that have publications, that have websites. So for instance, for over 30 years, there have been conferences specifically about women in astronomy with international participation. Or there have been conferences, workshops, symposia on inclusivity more broadly. So looking not just at women, but looking at disabled people, looking at members of sexual minorities, LGBTQ astronomers. And these kinds of conferences are sort of scientific conferences where people share scientific results, but they're also sort of networking events where people can come together and form and reinvigorate a particular movement as well. Sometimes these conferences have produced manifestos, and these are documents that are, yes, written by scientists, but they are written in a way that people who are non-scientists can read them, and that people from various scientific specializations can read as well, which means you can read those as well. So even if, let's say, you don't have a particular background in astronomy, even if you feel your own mathematical foundations is a little bit weak, if you feel like that if there are a lot of equations in a paper that might put you off, these manifestos typically have no equations at all. So for instance, here there's the Baltimore Charter for Women in Astronomy from 1992, here published in 1993 in the Space Telescope Science Institute newsletter. The Space Telescope Science Institute is this institute that manages, by the way, the Hubble Space Telescope and the James Webb Space Telescope. And here it starts with a saying, women hold up half the sky. Here it says it's an ancient Chinese saying. It's actually a saying that is attributed to Mao Zedong, so the communist Chinese leader. Women hold up half the sky. And you can see with that preamble, there are no equations here. This is not complicated stuff. And in many ways, this makes sense. This made sense over 30 years ago, and this still makes sense. So women and men are equally capable of doing excellent science. Diversity contributes to rather than conflicts with the excellence of science. Current recruitment, training, and evaluation and award systems often prevent the equal participation of women. So here, talking about the kind of obstacles that women face. And comes with recommendations. So these are recommendations from 1992, but in many ways they, but these recommendations still stand. That affirmative action involves the establishment of serious goals, not rigid quotas for achieving diversity in all aspects of the profession, including hiring, invite to talks, committees and awards, right? So that if, for instance, there's an institution that does not have enough women astronomers, maybe a quota might not be the right way, but sort of having some kind of goal where, yes, we want more women at our institution. Here it says 1992, strong action must be taken to end sexual harassment. Education and awareness programs are standard in the US government and industry and should be adopted by the astronomical community. It says gender neutral language and illustrations are important in the formation of expectations. Last point here, physical safety is of concern to all astronomers and of particular significance to women who often feel more vulnerable when working alone on campus or in observatories, right? So physical safety is an issue for people, for women everywhere, but especially, right, if you're looking at astronomers who work at night, who work at observatories, right, sort of making sure that sort of women feel safe at their workplace, that they're safe from threats of sexual harassment, threats from rape, from any kind of violence. That's really important. That was important over 30 years ago, and it's still important. A lot of the problems have unfortunately not been solved, but people are still working on those. 2015, so this is 10 years ago, out of the Inclusive Astronomy Conference in Nashville, Tennessee, came recommendations that were not just about women, but it was it was a conference that was trying to support people from various different identities. So people of color, lesbian, gay, bisexual, transgender, genderqueer, gender fluid, agender, intersex, queer, questioning, or asexual, LGBTIQA star people, people with disabilities, women, people disenfranchised by their socioeconomic status, and everyone who holds more than one of these identities in the astronomical community. This is a document that was made in America, but people from these kinds of identities, right, women, people with disabilities, people disenfranchised by their socioeconomic status, LGBTQ people, they exist in every country, right? So you can probably write in Pakistan or elsewhere, you can write about the status of these communities in astronomy and in all the sciences. And so these are recommendations for removing barriers to access, creating inclusive climates, right? So for instance, here is mentioned microaggressions. So yes, things like physical safety are important, but also like trying to avoid microaggressions at an institution to make it welcoming to people from every background. Improving inclusion and access to power, policy, and leadership. Establishing community of inclusive practice. So you can see here how these kinds of conferences, we're not just trying to bring women or people of different identities together, but they've also tried to forge a community, try to forge a movement, try to bring people together as scientists, but also as activists. A lot of these committees, groups, movements that have been formed over the decades, they still exist, and they exist in some kind of institutionalized form, which means they have websites, they have social media groups, they have newsletters, they have email listservs. So you can look up all of those. The American Astronomical Society, for instance, has a committee on the status of women in astronomy, a committee on minorities, a committee for sexual orientation and gender minorities, a working group on accessibility and disability. The International Astronomical Union has different working groups on women in astronomy, astronomy for equity and inclusion, and sort of, for the sake of disclosure, I'm an associate of the International Astronomical Union. I'm a member of one of their working groups on star names in particular. We're trying to make star names, the naming of stars, more inclusive, trying to, if we give new names to stars, have names from different cultures, different languages, different regions represented. And there are also amateur astronomy groups like Astronomers Without Borders, whose title mirrors, for instance, Doctors Without Borders and similar organizations. So if any of you are interested in writing about these kinds of communities, you can find them all online. Many of their material is freely available, so you don't have, you're not encountering any paywalls. For instance, many of the people, they're very, very open, friendly. If you identify yourself as a journalist or somebody who's interested in working with them or writing about them, I found these groups to be very, very welcoming and inclusive indeed. So why should you be interested in writing about these groups? Why have I also been interested in writing about these groups? Also because they make for interesting stories, right? These struggles of people from less powerful groups to make it in an elite field of science, to sort of reach the top of mountains, reach the stars. They've not been easy. So there are lots of like battles that needed to be won, hurdles that needed to be overcome. A lot of those that make an interesting story. So there's drama. And so if you engage in science writing, yes, you want to write about some kind of discovery or advance, but ideally you would also be interested in maybe an element of drama, right? An element of suspense. So for instance, this is from a document from I think let me see, from the 1990s as well, about, well, it actually goes back to like 1987, about images in astronomy, well, about degrading images of women in particular. So maybe I should bring you back to that period of the 1980s. In the 1980s, yes, you had women astronomers, but when you came to like the technical workshops, right, the area where engineers work, these were still very male-dominated spaces. So in America, as well as in other countries, you've often had in these male-dominated engineers' rooms, you had Playboy issues and posters of sort of half-naked women in essentially these workplaces, government workplaces, and people complained about them, and so feminists demanded the removal of such posters. Nowadays, probably everywhere in the world, it is a no-brainer that sort of you wouldn't have a poster of sort of a like half-naked woman in a government workplace. But these were still fights that needed to be won, at least in America, and at least in many other countries. There are still many ongoing struggles. So for instance, one of the best places in the world to do astronomy is Hawaii. It's sort of isolated, it's in the middle of the Pacific Ocean, and it has very, very high volcanoes, in particular Mauna Kea, a very high mountain where you have excellent views of the stars, excellent access to the heavens. Well, guess what? If you have excellent access to the heavens, you have wonderful views of the stars. It is very, very likely that this kind of place is not just of interest to astronomers, but it's also sacred to indigenous communities, right? If sort of you have a place where you are high up there, you feel as if you could touch the sky. You're so close. But well, then it's likely that people see this kind of place also as holy. In Hawaii, there's an ongoing conflict between indigenous Hawaiians who see the mountaintop of Mauna Kea in particular as sacred, as religious, and a conflict between astronomers who want to just keep building telescopes there. There have obviously, like in America and in many, many other countries, there have been ongoing problems with racism, with xenophobia. This came to a flashpoint at the beginning of the COVID pandemic in 2020, when the Black Lives Matter movement resulted in, for instance, the George Floyd protest. There was a movement to shut down academia, to shut down STEM, as a way to show solidarity with Black people in America, in particular. So here, even if you think that astronomy might be very, very distant from the politics of the street, it can get very close to it at times as well. So there are flashpoints, there are battles in the streets, on social media. And for instance, if you are on social media, you can find many of the controversies about racism, feminism, sexism, Islamophobia. You can trace those on social media as well as in newsletters, also on websites such as Inside Higher Ed, or such as, this is from the Wall Street Journal, where it's about an article about ideology and ideological battles in science. So all of this is actually quite interesting stuff to write about. So even if you're not interested in black holes, not interested in binary stars and all the wonderful objects that there are in the universe, there is a lot of politics related to Earth, related to the here and now, the planet where we live, in astronomy, that might be of interest to you. Now, I mentioned sort of social media activism, right? Sort of people fighting, arguing on X, formerly Twitter, arguing on Facebook, and so on, about sexism, about racism, and so on. So some of this activism seems to be very recent, right? I mentioned this abbreviation LGBTQIA star plus. Some of these abbreviations might seem quite recent, but activism in science is not recent. So if you are, like me, interested in history, you can also like trace back this activism more into history and sort of write about it. So I mentioned Albert Einstein earlier. Albert Einstein, he was an activist himself. He experienced discrimination as a Jew in Germany. When he went to the United States to escape Nazism, he encountered the racism against the black people in America, in particular in Princeton, New Jersey, the town where he settled, and he immediately built connections with the African American community, trying to help them overcome the racism that they faced, just like he had faced racism in Germany earlier. There have been organizations trying to fight racism, such as UNESCO, that astronomers have been involved in, such as Harlow Shapley. He was director of the Harvard Observatory. He wrote, for instance, already in the 1940s, 1950s, about the scientists having a duty outside the laboratory, outside the observatory. There have been efforts throughout the 20th century to overcome the barriers faced on based on nationality, right? Nowadays, right, people from the global south, in particular, have faced barriers based on passports, based on borders, right? I'm not sure whether any of you have ever filled in an application for a Schengen visa or for a UK visa. Then you kind of know the barriers that still exist. Astronomers have been trying to overcome these barriers with international observatories. This goes back to the 1940s already, where this is Harlow Shapley again from the Harvard Observatory. He writes, some German scholars claim that Copernicus was a German, and Polish scholars insist that Copernicus was a Pole, but I suggest that both represent the true situation. Copernicus was a terrestrial. So a lot of astronomers, they would try to overcome a national identity, and they would say, if we are astronomers, our address is Earth. That's where we are. That's our observing location. That's where we observe the universe from. Yeah, and there have been commissions, for instance, such as the commission of the International Astronomical Union, that has tried to give scholarships for astronomers to cross national borders for decades and decades. I'm sort of going fast here because I want to make sure we have enough time for questions. This is this particular commission for the exchange of astronomers using money by UNESCO. I mentioned earlier an organization called Astronomers Without Borders, a wonderful organization led by founded by an amateur astronomer called Mike Simmons, an American astronomer who collaborated with astronomers around the world to build bridges between different countries. And he collaborated, for instance, with an Iranian astronomer called Babak Tafreshi to create a project called The World at Night that seeks to emphasize, yes, that we all live under the same sky. Here it says dazzling Venus hovers in the Texas twilight just hours after it's seen by sky gazers in Iran. So as you know, there have been lots of conflict between America and Iran. Here, two astronomers, one Iranian and one American, have tried to sort of basically use astronomy to unite people, to connect people, and saying, yes, there's the same sky above Iran and America. So this astronomy could really unite people and overcome these barriers based on politics and passports and borders and governments and so on. Some astronomers have then also been involved in cultivating an identity that is planetary, an identity where we should not identify primarily as sort of just being part of one race or one gender or one ability, but that we should all see ourselves as people of planet Earth, right? Astronomy, more than any other sciences, perhaps can create this kind of consciousness that, yes, we live on a planet. That's the place where we are born, where we live, where we die. But that's our home, essentially, more than a particular town or country, and so on. So this is essentially where I want to end at, is that maybe sort of some of the struggles that I've talked about can seem divisive, right? Where maybe people were fighting with one another to overcome sexism, homophobia, racism, and in trying to sort of get towards a more diverse, more inclusive, more equitable astronomical profession. However, these struggles do not necessarily mean that people are divided or always need to be divided, right? But that astronomy, as a lot of activists have always also tried to show, is that astronomy can be something that is for all, that is served by all, that is helping everyone on our planet. And hopefully, sort of, I would have convinced you with that message that even if you are not particularly interested in astronomy, even if you feel the mathematics is hard, if you feel you don't like the equations and so on, I hope to have convinced you that astronomy can be for everybody, just like the sky can be for everyone, that the Milky Way is all ours, and that maybe all of you, or some of you, will join me in writing about astronomy and astronomers. Thank you so much again. Thank you, Fawaz and Sadiqa, the Scientia Pakistan team, Kainat Studios, my research assistants, and my interviewees. Thank you.
Well, thank you for such a wonderful presentation, especially when you highlighted about the Global South and all the groups that have been excluded, and throughout the decades or more appropriately last centuries until today, what have been done, and you have identified the groups and everything. It was a very inclusive talk as well. So thank you. Now we can have some question for Dr. Determann, and we would love to answer. Would love to interact with you guys. So you can ask.
Any questions? I think you can put your question as well in the chat, but Muhammad Ali Saim Osmani is raising his hand.
Hello, Doctor. Thank you so much. I was really inspired by your message about how the sky is inclusive of everyone, and so should be, and so should all the fields in science be. My question was that you talked a lot about the recommendations proposed by different committees and conferences, but to what extent do you think those recommendations are being applied in the actual world?
To what extent are they being applied? That's a really, really good question. In some ways, we have seen progress. So, for instance, I feel that astronomy has become, in general, a safer place for women. This is part because of like the recommendations, the struggles, the feminist movement, but this is also in part actually due to technological progress. So, for instance, nowadays, a lot of astronomers, they don't actually observe throughout the night in a cold observatories in the darkness. A lot of astronomers nowadays, they can download data from a space telescope or another kind of telescope, and essentially just run algorithms and run computer software on this data and publish those findings. So nowadays, right, if you're a woman and you feel like that you feel unsafe to sort of work at night at an observatory far remote outside of the city, well, nowadays you can just stay well, almost wherever you are with an internet connection, but sometimes access the data without downloading it, just keeping it in the cloud, and sort of publishing papers that way. And sort of a lot of this data is freely available, right? So you don't have to worry about GDPR. You don't have to worry about data privacy. The sun, the planets, they don't have data privacy. If you have data about them, you can share it with everybody. And sort of everybody can download data from NASA, for instance, and work with it and publish it, and so on. We have seen a lot of progress there. A lot of also, if you're a disabled person, technology is nowadays great, right? If you're a blind person, you can use technology to read papers to you, read out loud papers for you, where you can just listen to papers and so on. On the other hand, right, unfortunately, science is still a very, very competitive place. Right, a lot of universities, they're trying to compete with one another over like university rankings, being a top 100 university, etc. Research teams are trying to collaborate with one another. People are competing with one another over the win the Nobel Prize. And as you know, right, sometimes when people are very competitive, they can also not be very collaborative. There is the danger of that, where people can be nasty towards one another and trying to be the push out competitors. And if you're, let's say, from a vulnerable group, right, if you're a woman, a person from a minority, a disabled person, and sort of you can have powerful people who are sort of trying to push you out. Unfortunately, astronomy can still feel a hostile place to you. So yes, we've seen progress, recommendations, especially surrounding physical safety. Is the situation perfect? Are all women perfectly safe on university campuses? No. Do women, for instance, never have to worry about sexual harassment or rape or all these, or violence in general? Unfortunately not. So there's still a lot of work to be done. We still need a lot more recommendations, and not just recommendations.
Well, amazing. Okay, so if anyone has another question, they can always put in the chat as well. And well, yes, we can quite agree on that. Dr. Determann, you are quite right that when we are talking about astronomy, it has whatever has been emphasized and recommended and advised by these bodies and working groups. It has quite implemented as compared to other fields, and especially socially, and even as we were talking about politically, astronomy still has some exclusion, but what we could see on websites of these organizations and people in these organizations, they are collaborative and they are quite able to hear. So that's it. Okay. So well, seems like there is no question. Could you please tell us about your upcoming book and what it covers? We would really love to hear about it.
Thank you. So my current book project is a history of teaching science with science fiction. It is in some ways also related to inclusion, right? It is a lot of people have found that a lot of sciences are not very appealing as such, right? That a lot of people get put off by subjects like physics and so on. A lot of people find it too hard. Like there is also a gender element sometimes where I have a 6-year-old daughter who sometimes feels that, oh, mathematics, that's sort of something more for the boys, or like space is something that's more for the boys. And a lot of people have actually tried to sort of broaden the appeal of science by connecting it with science fiction and speculative fiction more broadly. So if you look at some of the most popular movies from the 21st centuries, they've been science fiction or speculative fiction or fantasy movies. Think about Star Wars, think about Harry Potter, think about Avatar, superhero movies, right? So there have been books, for instance, written by people on the physics of Star Trek, the science of Harry Potter, the science of Star Wars, the science of superheroes, sort of trying to teach science through these popular culture examples by, for instance, showing, yes, this is the wrong science in a superhero movie, but here's also the right examples. And even from the wrong science in superheroes, when superhero movies tell things that are impossible, here there are actually things that you can learn about science. So I'm looking at educators who are sort of trying to popularize science, make science be appealing to the masses by connecting it through to science fiction. That's the current project.
Well, that's really amazing to hear. You're always pushing the boundaries, and well, also, and I guess